Myself, Madhuri Modak, Assistant Professor in Mathematics, Department of Computer Science, Abhiday Namdar, Senior College. Now, in groups and coding theory, we start with the last unit, that is coding theory. Now, we have seen what is the meaning of encoding function, group code, Hamming weight, Hamming distance, etc. Now, we define parity check matrix. Let m and n be non-negative integers with m less than n and r is equal to n minus m. And n by r Boolean matrix H equal to H11, H12, H1R, H21, H22, H2R, HM1, HM2, HMR, and last R by R rows form an identity matrix. Such a matrix is called as a parity check matrix. Now, Boolean matrix means a matrix whose entries are either 0 or 1. Now, first M rows contains either 0 or 1 and the last R rows form an R by R identity matrix. So, these M rows and last R rows. So, there will be total M plus R means n rows, and how many columns are there? R columns. So such type of matrix H is called as the parity check matrix. Now we use H to define an encoding function EH from Bm to Bn as follows. Now every element of Bm is an m tuple and every element of Bn is an n tuple. If B equal to B1, B2, Bm is an element of Bm, then X equal to EH of B, we define it as B1, B2, Bm, X1, X2, XR. Now the first M tuple B1, B2, Bm remain same. And additionally there is X1, X2, XR which we have to calculate by using these equations. Now R plus M. So from this R plus M is an N. So the element EHB equal to X is an n tuple. So it is an element of Bn. Now see how to calculate X1, X2, XR. So X1 is equal to B1 H11 plus B2 H21 plus and so on Bm Hm1, which is actually the row B1 B2 Bm multiplied by first column of this matrix. Similarly, X2 is equal to B1 H12 plus B2 H22 plus and so on Bm Hm2, which is nothing but row B1 B2 Bm multiplied by the second column of that matrix. Similarly, XR is equal to B1 H1R plus B2 H2R plus and so on Bm HMR, which is equal to B1 B2 Bm multiplied by the rth column. So in this way we have to calculate every element separately x1, x2, xr, and then we can write x equal to EH of B, which is B1, B2, Bm, x1, x2, xr. Now next theorem, let x is y1, y2, ym, x1, x2, xr is in Bm. Then x star h is 0 bar if and only if x equal to EH of B for some B belonging to Bm, where H is parity check matrix. Now its corollary is important. EH of Bm is equal to EH of B. B in Bm is a subgroup of Bn. That means EH, which is nothing but the encoding function obtained by using that parity check matrix, is a group code because it is a subgroup of Bn. Now the question is determine the group code EH from B2 to B5 where given parity check matrix is this matrix H. Now in this case the question is like find the group code or determine the group code, because as EH is nothing but the encoding function for parity check matrix, and by this corollary EH of B2 will be subgroup of B5 and hence it must be a group code. So the question is like determine the group code. Now to determine the group code for all elements of B2, that means for 0, 0, 0, 1, 1, 0 and 1, 1, we find all code words. Now B2 is 0, 0, 0, 1, 1, 0, 1, 1. We determine the images EH of 0, 0, EH of 0, 1, EH of 1, 0 and EH of 1, 1 by using the definition. Now by definition EH of 0, 0 will be 0, 0, x1, x2, x3 because as it is an element of B5, it is a 5 tuple. So remaining three elements x1, x2, x3 we have to find. Now x1 is this 0, 0 multiplied by the first two rows because the last three rows is nothing but 3 by 3 identity matrix. So 0, 0 multiplied by first column 1, 0. So it will be 0 into 1 plus 0 into 0 which is 0. How to calculate x2? Again this is fixed row 0, 0 multiply by second column. So 0, 0 into second column 1, 1. So it is 0 into 1 plus 0 into 1 which is 0. Then x3 is equal to 0, 0 row multiplied by 0, 1 third column. So it is 0, 0 into 1, 0 which is again 0. So all x1, x2, x3 are 0. So finally EH of 0, 0 is equal to 0 5 times. Similar way, while finding EH of 0, 1, 0, 1 that equal to 0, 1, x1, x2, x3. Again we find x1, x2, x3 in the same way. So x1 will be 0, 1 multiplied by the first column. Then x2 will be 0, 1 multiplied by second column. x3 will be 0, 1 multiplied by third column like that. So in this way we have to calculate all the elements. So finally we get all the code words. So required group code is set of all code words, set of all images under EH, which is 0, 0, 0, 0, 0 5 times, then 0, 1, 0, 1, 1, 1, 0, 1, 1, 0 and 1, 1, 0, 1. So this is the required group code. Now one more, let H is equal to, now this is the parity check matrix given to us. Determine the 3-6 group code EH from B3 to B6. Again by corollary, EH of B3, that is the set of all code words, is always a subgroup of B6 and hence it is a group code. So we find EH of B3, that is set of all images of elements in B3 under EH. Now if you observe this matrix H, the last three rows form an identity matrix. So we use first three rows for calculation. Now B3 contains how many elements? 2 raised to 3, that is 8 elements. So this is our set B3. Now we find all code words. So EH of 0, 0, 0 is equal to 0, 0, 0, x1, x2, x3. Again, x1 will be this row 0, 0, 0 multiplied by first column 1, 0, 1. So it is 0 into 1 plus 0 into 0 plus 0 into 1 which is 0. Same way, x2 is equal to this row 0, 0, 0 multiplied by second column 0, 1, 1. So it is 0 into 0 plus 0 into 1 plus 0 into 1 which is 0. Same way, x3 equal to 0, 0, 0 row multiplied by last column 0, 1, 1. So it is 0 into 0 plus 0 into 1 plus 0 into 1 which is 0. So EH of 000 is equal to 006 times. Similar way, while finding EH of 001, we write 001 x1, x2, x3. Now how to calculate x1? It is 001 row multiplied by first row, that is first column 101. So it will be 0 into 1 plus 0 into 0 plus 1 into 1. Now this is 0, this is 0 and this is 1. So finally it is 1. Same way x2 will be 001 multiplied by second column, that is 011. So it will be 0 into 0 plus 0 into 1 plus 1 into 1 which is equal to 1. Same way x3 equal to 001 multiplied by third column, that is 011 which is again equal to 1. So we get EH of 001 is 004 times 1. Similarly, we can find the remaining code words. Now we form the set of all code words, that is the required group code.